we have this topic for today. It's about polynomials, but we are in the unit that we are studying right now in a college calculus. It's a mathematical models. I mean, it's a catalog of essential functions. This means that we have to talk about around the function. Okay, all problems about function, but we have applied those functions like models in real life problems. Like this one, we have one problem here for today. This is a real problem. It's very simple. Just I'm gonna review some ideas before to solve this question. For instance, we have functions or polynomials. Let me talk a little bit about the polynomials. Like this. This is 2x to the 6th power minus x to the 4 plus 2/5 x to the 3rd power plus square root 2. This is a polynomials. This polynomials has a degree 6 degree. How find the degree of our polynomials? You find the degree of polynomials looking for what is the highest exponent in the term of the polynomial. In this case, the highest exponent in one variable, this is 6. So therefore, the degree of these polynomials is 6. Let me show another one. Polynomials, because our class is about today about polynomials. We are going to apply in the real life to solve real life problems. You write another problem. Let me write this. Equals ax to the 3rd power plus bx to the 2nd power plus cx plus d. When a is different 0, this polynomial as the degree is the third degree. Third degree is the maximum. Also we call this polynomial a cubic function. This when you work in the real life is a cubic function. See, cubic function. We have examples with a cubic function, like for instance, when you have the graph like this. For instance, let me write so here one. Just give it to you the idea. If you write the y here equals x to the 3rd power minus x plus 1, this function you can wrap like this in the graph. You can make the picture so like this. This function is a cubic polynomials. Cubic polynomial is the degree is cubic. We have another in polynomials. Also, we have to talk about quadratic function like this one. Y equals x squared minus x plus 1. This is a quadratic function. Also, when you make a graph of quadratic function like this, you're gonna have here 2 and then 1, something like this. This function, the graph for this function is like like this. Okay. Also, let me show you another case about polynomials, about function. Let's write 2x and y equals 2x squared. This is a quadratic plus 3x plus 1. This quadratic function, you want to graph. The graph is shown like this. is 2 and 1 and 0. You make a graph for this function. Is gonna be like so. That's not exactly. It's just I am trying to show you what I mean. This to conclude. When you work with this quadratic function, always the graph is a parabola. The quadratic function, always the graph are a parabola. Okay, so now let's go to our problem for today. Just some ideas to refresh your mind about polynomials. Okay, we are talking about polynomials. A function p is called a polynomial if px is equals an x n plus an minus 1 x to the n minus 1 plus some numbers plus a 2x to the second power plus a1 x plus a0. Okay, this is a polynomial. Okay, let's go to talk about and try to find the answer of this question here. A ball is dropped from the upper observation deck of the CN tower, 450 meters above the ground, and its kh above the ground is recorded at 1 second interval. Find the model to feed the data and use the model to predict the time at which the ball hits the ground. Remember, this unit for college calculus talking about mathematics models. We are going to find a model using the polynomials, I mean the function, a function here. We have, I dropped this table here about, this belongs to our problem. For example, you make a graph, because you want to do the graph of this, of course, we are able to graph here. So I'm going to try to make the graph. I'm going to erase it. But this is the meters, and this is the seconds. The seconds, and then in the seconds right here, the numbers we have 1, 2, 3, 4, 5, 6, 7, 8 seconds. Okay, and then the height or the meters we have like 200 and then 400 like this, right? And then the lines. The line here is also 450 right here to night here. So it's t here, t times. It's times it's like this. Wanna be like that, right? Our graph. You work deep and seriously in this problem to understand how make mathematics models. Try to use a millimeters or square paper, or at least in the computer is more exactly to see each point this. But anyway, I'm going to write some information or data tables. Give it to the clue to find the answer. Okay, first, the height. The height is equals 449.36 plus 0.96. This is a data that we have collected minus 4.90 t squared. I'm going to apply the quadratic function to solve this question. So the model to find the answer to this question. Okay. We need to organize this problem as a quadratic function. So it started like this, minus 4.90 t to the second power plus 0.96 t And then plus 49.36 equals of course 0. That's our quadratic equation. So this is the quadratic. We are going to apply to solve this problem the quadratic formula. So the quadratic formula is going to be like this. T, apply the quadratic formula here. T is going to be equals like this, minus, remember the quadratic 0.96 plus minus, remember square root all data that we have here. So right here 0.96 to the second power minus 4, remember the quadratic formula, 4 times negative 4.90 times what is this, 449.36 divided by 2 times minus 4.90. So that the quadratic formula make the whole process. I do not do the step by step. I don't have enough time. Just I'm gonna give it to you. I am giving to you the clue, the main idea, to help you to find easier the answer to our problem. But I am trying to show you how the model, the mathematics model works in these cases using polynomials. In our case, I'm using the quadratic formula to find the answer. So what is the conclusion? Our conclusion should be, if you go to the end of the problem, the positive, the positive root, see, is t equals, not exactly, so because it's not the exactly number, 9.67. The t. Then we here this is the answer. So look at the question. The question, go back to the question. Find the model to feed the data and use the model to predict the time at which the ball hits the ground. What is the time? So we predict that the ball will hit the ground about after hit the ground. Let me write here, hit the ground, because I given the answer, the ground after about 9.67 seconds. See? This is our solution, our problem. So this is the mathematics is good for. So when you have real problems in your life, using mathematics, it's very easy to find the solution like this problem. Just keeping in mind, watching the video again. So I did this table to help support our problem, and then see how solve this problem using polynomials. Polynomials, I mean this function, quadratic function, to find the answer to real problem. Okay, this is a real problem, and then the answer is right there. So please practice all development all the formula step by step, and